would like to welcome the first speaker, Brad Swartzwelter from Amtrak, who will talk about understanding the over and under question for Hyperloop right-of-ways. Please welcome.
Hopefully that works. Thank you for the kind introduction. I've been a railroader for 24 years. So I know from the inside out just how challenging and frustrating existing transportation technologies can be. So starting in 1996, I committed myself to finding the very best form of transportation possible within our understanding of physics and engineering. And the good news was a group of people were already working on just that in Switzerland. So I traveled to Lausanne, and I spent some time with Dr. Michel Mossy, then director of SwissMetro, who, by the way, was advised for his PhD by Dr. Juffer. And I also had a chance to do an extensive interview with Dr. James Powell, the father of American maglev and the father of Jesse. I had a great chance to have a long conversation with Dr. Sam Gural about how urban maglev would work in a vacuum tube environment. I got the chance to interview Dr. Dick Post at the Lawrence Livermore Institute, who had some earth-shattering technologies that we might see coming to bear from one of the Hyperloop companies as well. Just a tremendous number of people that I was able to interview, and I kept looking for the technical showstopper. I never found it, and I still haven't. Financial issues, sure. But in the end, with my research, I chose to write a book, and it was called Faster Than Jets, A Solution to America's Long-Term Transportation Problems. And it was published 15 years ago in April of 2003. Years went by, and vacuum tube maglev just didn't get any traction. So you can understand how excited I was in 2013 when Elon Musk said, I have an idea. And by the way, you'd think that for borrowing an idea, I could get set up with a car or something, but never mind that. It was a wonderful, wonderful thing because it sparked this industrial revolution that is profound and has tremendous implications throughout the entire century. Just to put it in personal terms, when I saw the video of the wheels lifting off the rail of a levitating pod as it accelerated through a vacuum tube, I mean, I don't know about you, I literally cried. That was vindication, that this works. And so I could talk for a long time about how what I wrote in the book and what's happening today in the Hyperloop world are similar. But what's interesting is how what I wrote about and where Hyperloop seems to be going diverge. And the big issue is alignment. My idea, and it was the SwissMetro idea, was that the entire structure would be underground. While most of our companies that are putting Hyperloop together today have a combination of above ground on pillars, across the surface, or underground as needed. So to compare those three alignment options, I think the best thing to do is look at ways that Hyperloop is far superior to other modes of transportation, and then compare the three alignment options within that context. So we have Hyperloop alignment comparison and several categories, and we'll start with speed of travel, because that's what's really exciting. That's what gets the public excited. That's what sells the whole thing. For land-based transportation systems, speed is all about straight lines. Curves kill speed. If we're going to hope to sustain 900 kilometers an hour on Hyperloop, there's no way it will happen on the surface because topography and development are going to force curves. Underground, it's very possible to avoid topography and curve interference and dig laser straight lines for even hundreds of kilometers and achieve the speed we hope to get. The second issue is safety. 6 times in my career as a railroader, I've been in charge of trains where people have died because of the train I was on. Every one of them was a trespasser on the tracks, and not one was a passenger on the train. And still, those are the worst days of my entire career. So you can understand why I get very passionate about this issue. So if you forget everything else I say, which is possible, please remember this one statement and let's make it an industrial ethic. Nobody ever dies because of Hyperloop. If we have that as our industrial ethic, we'll be way ahead of the regulators. And in fact, I believe they'll become partners and advocates in the commercialization process rather than barriers to deployment. Nobody ever dies because of Hyperloop. So the safety systems inside the three alignments are going to be about the same on the inside of the tube. So the question will be impacts from the outside. If the alignment is on the surface or on pillars, occasionally cars are going to hit those pillars, and sometimes the people in those cars are going to die. And then Hyperloop will have failed to be completely safe. Also, terrorism has to be considered. Hyperloop is going to be a showcase of modern technology. And that alone will make it a terror target, even if the number of people that could be killed in a potential attack would be small. I don't see any way that a Hyperloop pipe on the surface could survive a gunshot from a .50 caliber rifle without suffering a breach of the tube. Air would rush into the tube at an incredible velocity and violently buffet a pod that then would pass by at hundreds of kilometers per hour. It'd be like driving a race car. If you've ever driven a car 200 miles an hour, which I've had the opportunity to do once, even the slightest shift in wind is terrifying. Now imagine tripling that speed, doing it inside a confined space with only centimeters of clearance, and going through zero wind into the face of a hurricane in a millisecond. Call me skeptical. I think its survivability would be questionable. Conversely, a direct hit by a nuclear weapon above a Hyperloop line protected by 50 meters of earth would be protected and still functional. So I think when you compare the alignment options, you have to say that safety is going to be best served underground. Perhaps the hardest part of getting Hyperloop deployed is getting through the environmental impact study. Whenever land is used on the surface, it takes away that land from other uses and living things. Even the shadow of an elevated pipe is going to have an effect on the environment below. But every meter of track that is constructed underground creates brand new land for human activity. And at the depths we're talking about, the number of life forms that we interfere with are almost zero, a little bit of minor bacteria. So the environmental impact along almost 95% of a subsurface right-of-way is virtually zero. And that's why we're able to see the tunnel boring machine company already digging in places where other Hyperloop options haven't been able to get off the ground. There's a poor joke there. Sustainability. Tunnels last for centuries. Surface pipes and bridges exposed to the elements only last for decades. On the railroad I've worked for, there are 43 tunnels, and there used to be 25 bridges. The line was built in the early 20th century. Every bridge has been replaced twice. Most of them have been filled in with rock as culverts. All of the 43 tunnels are still almost exactly the way they were when they were blasted out in the first decade of the 20th century, because tunnels last. We're going to get sustainability out of the system underground, not above. Expandability. Underground, there's infinite depth and breadth for unlimited expansion. It's a whole clean slate. On the surface, the land is finite and it's already occupied. So if we're looking to have expansion large enough to handle the kind of growth that people are going to demand of Hyperloop as the century wears on and the system becomes fully accepted, it's going to have to be underground. And freight capability, and I loved what Ian said, freight is going to be exciting to the accountants far more than it will be to the passenger side. 70% of revenue to Hyperloop will probably be coming from freight if the system can handle existing intermodal containers. That means the pipe needs to be a little bit bigger and the beam has to be quite a bit stronger than what's usually proposed for Hyperloop. Underground, it's not that tough to get tunnel boring machines to be built just a little bit bigger so that we can handle intermodal containers. And you never have to worry about a pod being so heavy that it would cause a bit of a sag between pillars as the pod goes along, especially if it has to come to an emergency stop between pillars. Freight capability is going to be best served underground. Now we get into the costs of building the system, and that's why people think, several people think that the system will end up being primarily above ground. The first is land cost. Please listen closely to the enormity of what I'm about to suggest. I believe a political case can be made that would allow Hyperloop free access to the entire subsurface, just like airplanes have free access to the airspace owned by property owners below. This sea change of law is vital because Hyperloop's got to have the straight lines that it needs in order to achieve its potential speed. If a property owner's usability of that property is unaffected in any way and they can't hear, see, feel, or smell the construction or operation of the transportation corridor below them in any way, then I believe that the government should allow those rights of way to be built without the right of the property owner to be able to block or be compensated for the construction of that right of way. If we have that law, and I believe they can pass, it would be tough work, but I believe they can pass with the right messaging. If we have those laws, then I believe that the floodgates will open and we'll see the greatest expansion of transportation in history begin to take place. So if that happens, I believe that the land cost will go to the underground alignment option. But tunnels are very expensive to build. There's no way around that fact. It will always be cheaper to drape pipes across the landscape than it will be to dig tunnels. But the cost of tunneling has been dropping steadily over the years as the tunnel boring machines have become more automated. In all likelihood, I believe that with massive tunnel industry expansion because of Hyperloop, we will see the cost of tunneling drop to about $20 million US per kilometer. And at that rate, we're still going to be quite a bit higher than surface options, which will be just a little bit less than building an elevated system. But the cost difference won't be too great. Construction speed. When you're building something, speed of construction is all about repetitive automation. The modern tunnel boring machine, which is an earth pressure balanced shielded machine, can progress at an absolutely steady, repetitive rate that's almost autonomous with very few operators in the pit in a laser guided path. And in 80% of the world's continental geology, these machines can progress at 50 meters a day. In some cases, they've gone more. And at that rate of speed, the Hyperloop line will leave a laser straight, rock solid, dry space ready for the electromechanical gear to be bolted in. That's faster than repaving projects on existing highways, let alone trying to create brand new infrastructure with the mitigation of utilities and everything else that has to be involved. I believe that construction speed is going to be fastest underground once we have the processes in place and it begins working. So the total cost, it's going to be close for building, but I do believe that underground is still going to be a little less expensive than building a surface option, but the return on that investment over the long term will be enormously in favor of having the alignment be underground. So just a couple of things I hope you can remember. First is that our industrial ethic, I believe, has to be that no one ever dies on Hyperloop. Shinkansen has gone, what did you say, 50 years? 54 years. I should know that, I'm 54 years old. Never in my lifetime has a person died on Shinkansen. I have the highest hopes that the youngest people in this room today will be able to say nobody ever died on Hyperloop as their life comes towards an end. I believe it can happen. In underground tunnels, I think we have the best chance for that. Hyperloop potential can only be fully realized if the right-of-way is out of the way in underground tunnels. Of course, that's an opinion. I think there's an awful lot of reasons why. But if we do that, then I think we can also sell it. And that's what gets to the biggest issue of what I wanted to say that's perhaps novel, is that I believe we need legislation in the countries around the world for transportation that's similar to U.S. aviation law found in the United States Federal Code. With that, the sky's the limit for going underground. And I'd like to say just one last thing before I go to question and answer. I'm prepared, having led political campaigns on transportation issues in the past, one of them being creating a little ski train in Colorado that succeeded. It can be done. And I believe that possibly the best way to do that in the United States is to start small on a state level and then take that to the federal level. So that's what I have. Thank you very much, and ready for a question or two. Yes?
I have a comment on underground. I'm not sure that everybody or anybody, I'm sure people are aware of this, but anyway, I was in Tokyo a few months ago, and we took a train. And the train we took was 7 levels down the trench. And that was pretty amazing.
Absolutely.
There were 6 trains above us underground.
Yes. So the comment was that there were 6 levels of tracks before the 7th that he got on in Japan. And that's one of the beauties of having unlimited depth and breadth underground. We can have multiple layers where I can imagine, and I even wrote about this in the book, where close to the surface we have almost like a subway system. And then a little bit lower we have more like a commuter line. Below that, we could have a regional system that might go 40 or 50 miles, say, between Colorado Springs and Denver. Of course, I'm going to be Colorado-centric because that's where I live. But then at deeper levels, we can go very, very long. And when you dig tunnels, if you go every 50 kilometers and you have tunnel boring machines digging in both directions, you're only a few years away from completion of corridors that could be thousands of kilometers long. It's just a matter of money to have enough machines and to get that done. Yes?
We're running out of time. We can take one more question.
Dane?
Did your book 15 years ago?
Yes?
Did it resonate with anyone? If so, why? And if not, why not?
I'm just guessing here, Dane, but in 2004 there was a conference similar to this on future technologies, and a group of PayPal executives were there. I don't know.
All right. Thank you so much.
Thank you.